recording. Your homework for Wednesday is on STEM scopes. So I want to remind you that you can find it in your apps section where the 9 dots are next to your name on the top right hand corner. So if you go up by your name or your face, your picture, you see those 9 dots. You scroll all the way down to the STEM Scopes app, and you will see your assignment changes in forces in motion. And what you're going to do is you're going to read it. It's a short reading, has lots of pictures, lots of diagrams, so don't worry about that. I do want you to highlight the 3 main topics that stand out to you. I will be able to see your annotations and then answer the questions there. Okay. So again, if you want to get started, you can. It's not due until Wednesday though. It's meant to be your asynchronous classwork for Wednesday. Questions on that? I do want to point out that the activity we were going to do with the tennis ball and ping pong ball is going to be pushed to next class. So if you gathered those materials, please just save them for Thursday. If you did not gather those materials, I just want to remind you that you can use some alternatives. You could have a rolled up sock or like a rolled up piece of paper. We need 2 objects that can roll, one that is heavier than the other. Okay, questions on that? All right, let's go ahead and start with our warm up then. And your warm up, I don't think I've released it yet. Let me assign it to you. On Google Classroom right now, it is posting. You're going to see the warm-up called Balanced versus Unbalanced. Okay. All right, it should be posted now on your Google Classroom. And what I did was the very first question is your warm-up. And what you're gonna find is throughout today's lesson, I have numbered the questions in the slides to correspond with your formative. So right now, open it up. I'm missing a few people. Let me make sure I didn't skip them. So we're missing Jaden, and then Jazzy is here. Okay. So go ahead and answer number 1. Good. So I'm going to peep on you on Go Guardian. Again, you should have already gone to Google Classroom and opened up the formative. Balanced versus unbalanced. Again, this is simply a warm-up. So if you're not sure, it's okay. What's not okay is for you to sit here and do nothing, okay? So make sure that you're opening up the formative. And question number 1 says, what do you expect to happen in this scenario? So let me share that screen with our viewers here. Okay. So we're looking at this scenario here. In one complete sentence, what do you expect to happen in this scenario? Again, I want to remind you that this is the warm-up. There's no right or wrong. So what do you think? Okay. Annabelle, I left you a message right now. All right, let's see what some of you guys said. Well, let me see. There we go. All right, some of you expect the red team to win because the force is greater than the blue team. The red side will win because it has more force. Red side will win. They have one large and one small, while the blue side only has one big guy. Red team will win. Good, complete sentence. I like how this student is changing it. A lot of you are saying the red team would win here. Okay, so again, this scenario. Couple volunteers raising your hand. Who would like to share with us what do you think would happen in this scenario? Alexander, what do you think would happen?
What I said was that I expected the red team to win because they have more force than the left side.
Okay, thank you. Sanal, what would you say?
The red team has more newtons that they're pulling toward them.
Okay. Samori, what would you say?
Red team because it has like more people.
Okay. So all of those would be correct. And as we're seeing, some of you mentioned there's more people over here, more newtons, more force. So yeah, we would expect this cart to go to the right and the red team would win. So good. So again, this is a reminder of our activity that we did last week. If you didn't finish that, make sure you do so. I will be scoring those shortly. So if you are not done with the warm-up, go ahead and finish it up while I go through a couple reminders for the rest of us, okay? Again, this formative is going to be used as your synchronous classwork. So you see other questions there, 2 through 16. So you can't really go ahead though, because you need to see the image I post first. Otherwise, it's not going to make sense. The warm-up is considered part of your participation points, okay? I do want to mention improving your grade. I've been getting a lot of emails. Can you retake the quiz? Can you get extra credit? And the answer is no. I want to remind you that you can only redo synchronous or asynchronous classwork. That's it. And even then, you get 75% of the score back. You cannot redo quizzes, exams, or assessments, and you cannot redo participation. So it's very important excuse me, for you to participate during class, okay? I do not give extra credit to individuals. I give extra credit to the whole class. So for instance, the quiz you just took, again, we're gonna go over the quiz next class period. There was an extra credit question that all my students had the opportunity to take. I don't assign individually. If you do go back and improve an assignment, please either email me or click resubmit on the Google Classroom, because then this sends me an email and I am then reminded to go back in there and regrade it, okay? Questions regarding grades? All right, your cameras look good. Elijah, though, if I could see your face, please, and we're good. Good job, guys. Again, we're going to be taking more notes today. And I do want to encourage you, if you do it on paper and pen, that's perfectly fine. You can take a picture later or type it in your notebook. Your next submission is 2 weeks from now on the 21st. All right, here we go. Review all the time. Motion is when an object's position changes over time. You can calculate the speed of an object by knowing the distance and the time it traveled. You can even calculate distance and time if you know the other information as well. Velocity is the exact same thing as speed, but it has direction, okay? If velocity changes in any way, then we are accelerating. And acceleration is more than just speeding up. It could be slowing down or changing direction. Okay. We then went over different graphs, and we need to be careful to know what type of graph we're looking at because those lines mean different things. Okay. Now, last time we met, we talked about Newton's first law of motion. Annabelle, I left you a little comment. And it has to do with objects in motion, objects at rest, and that those things won't change until there's an unbalanced force applied to it. This is what we're going to be talking about today. We also know that Newton's first law is the law of inertia. Inertia meaning resisting a change in motion. The more mass you have, the harder it is to change your motion. The less mass you have, it's a lot easier to change it. Okay. And then finally, we defined force as a push or pull. And we know that the unit for force, I'm not sure if this got in your notes last time, so make sure you add it. The unit for force is a Newton or a capital N. All right, questions on anything we've learned so far? Because then we're going to jump into our new stuff. Okay. It's also going to be very important for you to communicate with me, go slower or go faster in that participants box. And if we were in real life, I could just walk around and check your notes. I can't do that. So please communicate if you need me to slow down. Okay. All right. Today we are focusing on balanced versus unbalanced forces. So notice this question is numbered. If you see a question with a number on it, then it connects to the formative. Okay. So if you go back to the formative, what do you think? Do you think this scenario here shows balanced or unbalanced forces? So go ahead and click your choice on the formative. Okay. What do you think? Number 2 on the formative. Then what we're going to do for each question, I'm going to ask some volunteers to share what they picked and why. I'll pick up to 3 people per question. And this is another opportunity for you to get your participation points. Okay. So balanced or unbalanced? What did you pick and why? Jonathan?
Balance because they have the same force.
Okay. Jazzy?
I chose balanced because there's the same amount of people.
Okay. And Sanal?
I chose balance because there's the same amount of newtons being pulled on each side.
Okay. So when we look at this scenario, this is showing us balanced forces. So you're right. These are balanced forces. So right now on number 2, I still have a handful of you that did not answer number 2. Again, you're not allowed to sit here and do nothing. Okay. So Elijah, Ian, Jaden's absent, Jocelyn. We need to make sure we're answering number 2. Okay. So now number 3. How would you define balance forces then? So these are balanced. So now put it in your own words. If you have no idea and you're afraid of being wrong, it's okay. I just need you to stay active and participate. So how would you put this in your own words? This is balance. So what do you think balance forces actually means? I'm going to clear your hands because I didn't do that earlier. I apologize. Okay. All right, let me see. Good. Number 3. We're all on number 3. Annabella, join us. Number 3. Samori, what would you say?
Two objects have the same amount of newtons or mass.
Okay. John, what would you say?
I would define balance forces as when two objects exert equal amount of force on something.
Okay. And Lila, what would you say?
Forces are equal.
Okay. So balance forces, and this is what we're going to add to our notes, right? So I'm asking a lot of you today. I'm asking you to take notes and do the go formative. So we're going to do this, okay? So balance forces is when the forces are of the same magnitude. I'm throwing in a new word. In opposite directions. So I want us to look at that word magnitude first. Let me back up a little bit. So balance force is when the forces are of the same magnitude in opposite directions. Okay, so magnitude. I want you to think about that word. Think about if you've heard it before, if so, where. And go ahead and raise your hand. Where have you heard magnitude? Oh, no, not raise your hand. In the chat box. Where have you heard magnitude before? Jocelyn, are you there? Annabella, are you there? Where have you heard magnitude? Go ahead and write it in the chat box. All right. A lot of us mentioned earthquakes, right? So magnitude. Let's say we're going to have an earthquake, and the earthquake's 2.3. In the participants box, are you worried about a 2.3 earthquake? Yes or no? Participants box, yes or no? Okay, a lot of you did in the chat. Try to go to the participants box. No big deal, right? 2.3, it's a snooze fest. You guys can sleep through that, no big deal. How many of you felt the earthquake like 2 weeks ago? Yeah? Okay, that woke me up too. Well, sort of. My husband yelling, earthquake is what woke me up, really. And now we're about to have an earthquake. And the earthquake now is an 8.7. Are you worried about this one? Yes or no? Oh, yes, right? I gave you the magnitude of the earthquake. So if we're going to have an 8.7, I've never experienced an 8.7 in my life. I think the largest magnitude earthquake I've ever had was like a 6 point something. And I was like, whoa. So yes, magnitude is the strength of. So we say that a lot with earthquakes. A magnitude of 8 points. Wow, that's a lot. And it's a numeric value, and that tells us how much force it actually has. Okay. Annabella, are you still there? And then we notice it also has direction. And when you guys did your PhET simulation, what was the symbol? You can just raise your hand. Don't put it in the chat box. Raise your hand. What was the symbol for direction? Do you remember in the PhET simulation? Gia, what was the symbol?
An arrow.
An arrow. And so when we talk about with forces, direction is shown with the arrow. And some of you mentioned in the warm-up that the arrow was larger or smaller, and we're able to see that force, okay? And so that arrow is very important to us when it comes to forces. Jocelyn, I'm leaving you a little message there. Same thing, Annabella. Sydney, are you there? There we go. Okay. All right, go faster or go slower? So when we talk about forces, we have two things. We have magnitude and direction. I like how Lila mentioned they're equal. So if they're equal or if they're the same, they're going to be balanced, okay? But in opposite directions, okay? All right. So notice there's no number on this question. So this is just a raise your hand opportunity. Actually, I'm going to take that back. In the participants box, yes or no? Will balance forces change the motion of an object? Good. So you're participating in the participants box, yes or no? A mass majority of you are saying no, and you're correct. Balance forces do not change the motion of the object. It will not affect the object's acceleration, okay? So now number 4 in the formative, what's acceleration again? A little bit of review. Ooh, a lot of you already filled it out. What's acceleration? Good, I have some students raising their hands already. They're ready to participate. Ethan, what's acceleration?
Acceleration is when you gain speed within periods of time.
Okay. Naomi, what's acceleration?
A change in velocity.
Okay. And Alexander, what's acceleration?
It can be when an object is either slowing down or changing its direction.
Okay, right? So it's more than just speeding up. It could be speeding up, slowing down, or changing direction over time. Some of you mentioned changing velocity. Make sure we include over time. Some of you on the quiz only gave me one of these, and so you didn't get full credit. You got partial credit on your quiz. So a full acceleration could be any of these 3 scenarios. I do want to point out that if an object is already in motion and it has an equal amount of force pushing back on it, for instance, like air resistance, and like the force of the engine going forward, if these are balanced, then the speed will not change, okay? So it's still gonna be in motion. So it not only applies to something in rest, but also in motion. Balance forces will not change the motion of the object, okay? Questions on that? All right, go faster or go slower? All right, here we go. Jocelyn left you a little message there. All right, it's time for our break. 3 minutes, get a snack, get some fresh air, stand up and stretch at the very minimum, okay? Here we go, 3 minutes. All right, is this an example of balanced or unbalanced forces? All right. I'm waiting for a couple more of you. I'm going to give you 30 seconds. So we need to move quicker on the formative. What do you think about this one? Is this one balanced or unbalanced? Jonathan, are you back yet? There we go. All right, number 5. I'm still missing a few of you. Annabella, Ian. All right. Raising your hand. Which one did you pick and why? Kaylee, which one and why?
It's unbalanced because the right forces have 50 more newtons than the left forces.
Okay. Eliza, what did you pick and why?
I put that it was an unbalanced forces because the right side has more people than the left.
Okay. And then Ian, which one and why?
I chose unbalanced because the I put unbalanced because the red side has more force against the blue side.
Okay, thank you. So you guys are all correct. It is unbalanced forces for this one. Okay, so again, that was number 5. Good, I see 100%. Woohoo. Now number 6. Then how would you define unbalanced forces? And you already know the definition for balanced forces. So you have a little bit of help there. Now put it in your own words on the formative. What do you think? I'm going to give our folks 30 more seconds before I start calling on people. So what do you think? So Maury, how would you define unbalanced forces?
2 objects that don't have the same amount of newtons.
Okay, thank you. Ethan, what would you say?
When one side have more than the other.
Okay. Sanal?
When they don't have, the forces don't have the same magnitude.
Okay. And Alex?
When one side has more magnitude than the other.
Okay. So all of those are correct. Unbalanced forces is going to be when 2 or more unequal forces act on the same object. Or it could also be when only one force affects. How about I just put 1? I'll just change this. When 1 or more unequal forces. That's funny. Can I change that now? When 1 or more unequal forces act on the same object. Done. Woo. Hopefully it doesn't take forever to load. Yeah. And there you go. Okay. So when 1 or more unequal forces act on the same object. I like how some of you mentioned the magnitude will be different. We also know that the direction could be different as well. Okay. So they could be working in the same direction. They could have different magnitudes. So that's where, remember, a force is both magnitude and direction. So good. Okay. Go faster or slower. All right. So this is one of those yes or no questions in the participants box. Will unbalanced forces change the motion of an object? Yes or no? In the participants box. Okay. You guys all said yes, and you're correct. So unbalanced forces will cause the object to accelerate. And we know that acceleration means to speed up, slow down, or change direction over time. Okay, and as Alexander is mentioning, because one side has more magnitude than the other, it's going to make the object accelerate. You're correct. Okay, questions on these? All right, I will give you a moment to write this down. I see several of you. You at least look like you're taking notes. I'm assuming you are. I was talking to Ms. Dean the other day. I was like, I should just do my normally I do laps in the classroom, and I like look at your notes in person. So maybe I'll just start doing laps in the classroom as if you were really here. I should like print out your faces and like tape them to the chairs and stuff. That would be more fun for me. Did I tell you I miss you? Because I do. It's lonely over here. All right. I'm going to be the crazy lady with stick students in her room. That's okay. Okay. Go faster or go slower. Somebody said they're ready for their break. Well, soon enough. Okay. All right. What do you think about this one? This is a different scenario. Number 7. What do you think? Is this one balanced or unbalanced? Balanced or unbalanced? Good. I'm looking on Go Guardian, and some of you are doing other things. Don't slow us down. Stay with us. It should take you 10 seconds to click one or the other, and I'm looking at the responses. It's a mixture. Some of you think it's balanced. Some of you think it's unbalanced. Go ahead and raise. I'm going to clear the hands. Sorry, Alexander. Go ahead and which one did you pick and why? If we can get some different voices in here, that'd be nice. Naomi, which one did you pick and why?
I picked unbalanced forces because there's only one arrow. The other side, there's no force pushing.
Okay, thank you. Lila, what did you pick and why?
I picked unbalanced forces because there's only a force being applied to one side.
Okay. And Alexander, your last one.
I said that it was unbalanced because there is no other side that's applying force.
Okay, so you guys are correct, right? It's not, in order for it to be balanced, we would need something on the opposite side pushing to the left as well. So you're right, unbalanced for this one here. Mia, make sure we're answering the questions on the formative. Same thing, Jaden. Let me refresh. That was number 7. Don't make me police you all day, okay? Number 8, what about this one? Is this one balanced or unbalanced? Annabella, you need to answer number 7 as well. So balanced or unbalanced? All right, let me see what you guys picked. We have a variety of answers again. And I still have about 6 of you that need to choose. So what did you pick and why? I have the same people. Any new voices want to share what they picked and why? Joseph, what did you pick?
I chose unbalanced because the newtons have a different numbers.
Okay, thank you. It's the same people. Kristen, what did you pick?
I chose unbalanced because the guy in the back has more newtons than the guy in the front.
Okay. And then Jonathan, what did you pick?
I chose unbalanced because they're moving in the same direction.
Okay, good. I had a couple students last period that because they saw a force on both sides, they got a little confused, but you guys caught on that they're going in the same direction. So this is unbalanced, going in the same direction here. Okay, so if there's no separation, then we are able to, if there's, and not going in opposite directions and they're not canceling each other out, they're not equal, then it is unbalanced this way. We're gonna hold off on our break a little bit, okay? So we have those movers still. Go ahead and number 9. If I were to ask you to find the net force, or another word could be like the total force, your PhET simulations asked for the sum of the forces. Go ahead on number 9 in the formative. What do you think? There's no wrong answer here. What would you think if I asked you to find the net force? How would you do that? Some of you are actually showing me the math. Some of you are writing it in words. Beautiful. Either one works. What do you think? How would you find the net force? Good. I'm looking on Go Guardian. You're answering number 9. Good. Jocelyn, we're a little bit behind. Let's catch up, please. We're on number 9 now. All right, Annabella, we're on number 9. Lila, number 9. All right, what do you think? Let me lower your hands. What would you do if I straight asked you right now to find the net force? What would you do to do that? So now what would you do?
I just added the 25 newtons and 20.
Okay.
And got 45.
45. Anybody else? So that's what I did. If we see this here, I took the 25 newtons plus the 20 newtons, and then I got 45 newtons going to the right. Okay. Now I want you to think about this. Why did we add? Notice there's no number here, so it's not on the formative. Why did we add? Any thoughts? Kaylee, why do you think we added this time?
Because both of the men are going in the same direction.
Okay. Kristen, why do you think?
Because it says sum, and sum is the total, like when you add.
Okay. And then, Kaylee, did I ask you already? Okay. And then Samori.
Because both of the guys are carrying like the object to the same direction.
Okay. So when we have forces, we are, if they're going in the same direction, hold on, you can't see that very well. If they're going in the same direction, we're going to add them. So add, make sure this is in your notes, right? The bright green stuff is important things here. When forces are going in the same direction. Now it's a little misleading. I wish the PhET simulation didn't say the sum, because in math, sum means to add. But not all the examples we're gonna see, are they gonna be in the same direction? So we might have to subtract sometimes, okay? Go faster or slower? All right. Let me see where we're at. Okay, we'll do one more slide and then we'll take our break. Okay. So go to number 10 now in your formative. What's the net force? So some of you assumed it was for the last example. That's not what it is. It's for this example. So if you put 45 on number 10, go ahead and delete it. And now, what's the net force in this example? All right, some of you are using words. Some of you are showing me the whole math. Some of you are just giving me the straight answer. All of those are correct. I want to make sure you are staying awake and you're keeping up with us. That's the whole point of this. All right, any volunteers want to mention what they got for the net force of this object here? Naomi, what did you get?
I got 4 newtons because there's 2 newtons on one side and 2 newtons on the other side going in the same direction.
Okay. Anybody else? All right, I see some thumbs up, like that's what you did also. So yeah, we would go 2 newtons plus 2 newtons equals 4 newtons. But here's my question for you. Did you include the arrow? This is a big deal. This is a big deal because forces are vectors. Vector is a big deal. Our little dancing friend here will tell you he is a big deal, okay? Vectors have both magnitude and direction. So if, let's say on the exam, you told me just 4 newtons, you would only get half points. You have to give me the arrow also. In what direction was this force going here? Okay. Questions. Last class, I had a bunch of vector quotes going across my chat box. You guys are much more reserved, I can tell. How many of you saw Despicable Me 2? Yeah? Okay. So vector, oh, you didn't watch it yet. Oh, that's on your bucket list right there. You gotta watch it. Okay? Yep, you watched it. Vector's fun. He'll even tell you magnitude and direction. Like he'll even tell you what his name means. He's very excited about being vector. Okay? All right, let's take our last break. And then when we come back, we will wrap it up. We're almost done. 3 minutes. Stretch, get a drink. He is a fashion icon, you're right. Some of us still need to finish number 10. And I forgot to pause the recording. So if you're watching the recording, maybe you got up and took a brain break. We'll see. Okay. All right. So then let's move on. Notice there's no number here, so we're not writing this on the formative. I just want you to go ahead and think about it. And then I'm going to ask some volunteers to raise your hand. What would the net force be for this example here? What do you think here? I'm going to give a little bit more time, hopefully get some new voices out there. Make sure we come back. I'm waiting for Ian, Ethan, Elijah, Bryce. What do you think the net force is?
50.
Okay. Sanal, what do you think?
I was gonna say 52.
Okay, Naomi?
50 newtons to the right.
Oh, I like how she gave us the units and the direction. So we do want to include everything. I'm sorry, that equal sign should be over here. So it would be 50 newtons going to the right. Okay. Number 11, why did we subtract this time? So why did we subtract? Elijah, are you back? Thank you, Ethan. So now we're on number 11. Why did we subtract for this one here? Good, I see some new volunteers, sort of, same people. Kristen, why did we subtract this time?
We subtracted because the forces are going the opposite way.
Okay, that's exactly what we needed to do, right? Since they're going in opposite directions, we are going to go ahead and subtract them. We found out that with the other type of forces, if they're going in the same direction, we would add them. So again, this is number 11. Let me refresh because I have a few of you who are not keeping up. Stay awake, stay with us. Annabella, Jocelyn, Justin, Kaylee, Mia, Sanal, it's showing it's blank. Let me refresh again. It takes sometimes a little bit, just like a little bit of lag. So number 11, we are subtracting because they are going in opposite directions here. Okay. All right. Now we have the arrow going to the right. I like how Naomi mentioned not only the direction, but she also mentioned the units. Dang it. So why is the arrow going to end up going to the right this time? What do you think? So Mari, right? Why the right?
Oh, I forgot to lower my hand. I don't know.
Okay. Alexander, why the right?
I kind of left my hand up there too.
Okay. Jazzy, I saw your hand go up. What do you think?
I think because the right has more newtons.
Okay. So let me hear from one more person. Jonathan, why to the right?
Because they have more force.
Okay, so as was mentioned, they have more newtons, they have more force. I like to think of it like sumo wrestlers. The bigger one wins, right? So if we have more force going that way, that's ultimately the direction the object is going to go. Okay? Questions on this? Annabella, I left you a little comment in the chat box. Jocelyn, I'm leaving you a comment in the chat box. Okay. Here we go. And we're all ready. Okay. So there's no number on this one. Let me lower your hands. Look at this one now. What do you think the net force would be here? Raise your hand if you think you know it. We have a different scenario. Good. I like seeing different names popping up. Good. Sharon, what do you think for this one?
0n.
Okay. Anthony, what do you think?
0.
Okay. Let me see if there's a new voice. Bryce, what do you think?
0n.
Okay. So let me ask first of all, Anthony, can you add? Why did you subtract?
Because they're going opposite directions.
Beautiful. So here it is 0 newtons. And one of my classes asked, well, what direction? It doesn't really matter because it's not going anywhere. So it's just 0 newtons. So in the chat box, would this be balanced or unbalanced? Write it in the chat box. Ethan, are you with us? Balanced or unbalanced? In the chat box. All right. 100% of you said this is balance. You're right. Another way to define balance forces is if the net force equals 0. Okay. So net force is 0. Motion will not change. You have balance forces this way. Okay. Questions for me? All right. We have 10 minutes. In this 10 minutes, I have a few more questions for you that I want you to work on your own pace, okay? So the first scenario is this numbers 12 and 13. You're gonna answer, are they balanced or unbalanced? And then go ahead and calculate the net force. Same thing for 14 and 15, but the forces are different in this example. And then finally, you're gonna draw a scenario for me. So go ahead and get started. We have about 10 minutes for these 5 questions. Some of you have already finished. If you are done and you're happy, then go ahead and click submit. And you're done there. I've been watching some of you on Go Guardian. Some of you have already started the homework during class. Which is okay if you're keeping up with the actual classroom discussion stuff, okay? Good. Good, I should see you on the formative, unless you're already done. All right. So number 12. Let me show you the slide because I see a lot of people pausing on the calculating the net force. So let me show you like this one. If they're going in opposite directions, we're going to end up subtracting them. And if they're going in the same direction, this one's better, then we're going to end up adding them. Let me take out all these words though. There we go. Okay. So number 13, you're actually showing me Good. I'm seeing a lot of great answers. I'm seeing your magnitude with units and direction. And direction. Go back to number 13. Make sure you have direction. Fernando, I'm leaving you a little comment on number 13. So number 13, you're actually going to calculate. Okay. All right. If you have questions, remember now is the time to ask questions. If you're not sure, Annabella, I want you to answer number 13, please. Same thing, Jocelyn. Okay. You still have plenty of time. If you're not sure, because some of you tell me you didn't finish because you didn't know how to do it, you're not allowed to sit here and do nothing. What you are allowed to do is ask questions. You could private message me. You could unmute yourself and say, I have a question. All right, a question came up regarding are they going the same direction? What do you mean? Tell me what question your question's for. Okay. So for those of us who are not sure what to do, I'm going to go ahead and share what your fellow students have done. Okay. So for number 13, well, for number 12, first of all, can I get a volunteer? What did you pick? Balanced or unbalanced for number 12? Balanced or unbalanced? Should I lower your hands again and not just cold call on you? All right, raise your hand. Balanced or unbalanced for this one here. Miley, what did you pick for number 12?
For number 12, I picked unbalanced.
Why did you do that?
Because the person on the left has more newtons than the person on the right.
Okay, good. So number 12, it should be unbalanced. And I'm scrolling through here and you all said unbalanced. Beautiful. Because they're not equal. They are opposite, but they're not equal. Now number 13. Now to find number 13, we are going to, since they're going in opposite directions, we are going to subtract them. Okay, so 75 minus 50 is 25 newtons. And I like how this student included the arrow and the units on the final answer. It's going to end up going to the right. For this student here, we want to include the units, newtons, and then on our final answer, we need to know in what direction. This student is telling us why, which is good, but I want to see a calculation. I want you to actually calculate the net force, okay? So this one, they accidentally added, but since they're going in opposite directions, we need to subtract them instead. So go back here and fix this. Some of you are explaining the why. I didn't ask you to explain. I asked you to calculate, okay? Okay, make sure we have units in there, arrows. and then number 14. So Maury, did I answer your question?
Yeah.
Okay. Lila, I think you're meaning on like the final answer. So yes, you would need to include the direction, even if it's a left arrow. Oh, you know what I didn't show you guys? To make an arrow, which most of you are doing, on the next to the 0 on your keyboard are the dashes. You can do 2 dashes, and then on the bottom where the question mark is, you see like the carets, the greater than and the less than symbols. So you just put that together, and that's an arrow. If you want it to go to the left, you do the less than symbol, 2 dashes, and then it's going to the left. Okay? When you are all done, I'm hiding your names, right? Okay, good. So when you're all done, which I can see, so this is what I see some gaps. Some of you are skipping the questions, and that's going to mean you're not going to get full credit for today's classwork. So make sure you go back, completely fill in the all the materials. When you hit the very end, go ahead and submit it. Now, I actually look at what you put in there. If you at least tried, then you get full credit. If you just put like, I like flowers, I don't give you credit for that, okay? All right, questions for me? Some of you have already started the homework, and Alexander did ask, can you highlight more than 3? Yes, yes you can. So your homework is on STEM scopes. You're going to open up changes in force and motion. And so I'll show you real quick how to do that. Here we go. So up here by your name are those 9 dots. I forget, what's one of the things you guys call this? The waffle or something? Yeah, it's the waffle. So then you click on here, you scroll all the way down to your apps in the bottom, and there's STEM Scopes apps. So then you click on this, and you should see immediately, again, I don't have the student version. If somebody wants to unmute themselves and tell us what you see when you click on this, I would appreciate it. Nobody? Go ahead, Alexander.
I left my hand up again.
Well, tell me anyways, when I click STEM Scopes.
Can I share my screen?
No, I disabled that.
Oh, okay. So when you click that, you press STEM scopes. Then on my screen, it shows basically all the assignments that you assign.
Beautiful. So the first thing you see are the assignments, and then you should see here your changes in forces and motion. Okay. All right. If you don't have any questions, you are free to go. Otherwise, I am here to help. So then, hey guys, I'll see you on Thursday. Remember to get a ball and a ping pong ball if possible. Stop recording.